I was working again on that speech filter. It's almost ready now, and found a problem that I had encountered before. Perhaps it's interesting to tell something about it. So here is the end amplifier. It is a TDA 2003. As far as I know, it was originally from Philips, but anyway, here is that filter again with the op-amp. And when I made it and listened with my headphone here, I heard a hum, and that's say more or less always when you work with sensitive pre-amplifiers, transistor pre-amplifiers, also in the past with tubes, but that's gone. Those days are gone in a certain way, of course. The hum. So I used here to connect all the wirings to from the filter to the end amplifier, not shielded wires. You can see it here, and these wires pick up hum, so they are sensitive. When you want to do this, say, in a more perfect way, you need, say, from the input here of the filter to the potentiometer on the front, shielded wiring, and you must shield the mantle only on one side, and also here to the end amplifier. Same idea. So what was the solution? In the first place, I had to make the impedance of the end amplifier lower. So I used here a 47 kilo ohm resistor here, 47 kilo ohm, to bring, say, the endless impedance at the input of the end amplifier. That's very, very sensitive. I brought it somewhat down. That always limits in a certain way the sensitivity, and thus also the hum level. But the most important thing was this: when I moved the front here to, let me show it, when I moved it so to the circuit, I heard a hum out of the, not out of the loudspeakers, but out of the headphone. And that's also always a good idea when you make a sensitive audio preamplifier. If possible, listen to it with a headphone, and that headphone will pick up much more info about the sound. Anyway, so what's the crux? The crux is here, and that is this transformer. This transformer has a stray field. There is an electromagnetic field around it. I've also talked about it earlier in the earlier video. And I had to mount it now in this very peculiar way. It's hanging in the circuit. But I tested that with the headphone on and then moving the front panel here to the circuit, and then manipulating the transformer with my hands to a position where there was no longer hum audible in the headphone. And this was that position. So you can see it's extremely strange. It hangs in a certain way in the circuit. But it is important, and also in the other filter that I made, speech filter, I had exactly the same problem. That means the reason is, of course, that this filter is extremely sensitive here at its input, and also the end amplifier is extremely sensitive for hum. So the wiring here picks up hum, but the orientation of the transformer is, say, crucial. And if it was possible, I had mounted this transformer, say, far, far away from the circuit, for instance here. It all had to be mounted inside a small box. So, good idea when you make such a circuit or a sensitive audio preamplifier use another type of transformer, not the one I've used here. This is from a telephone charger, and they are cheap, they have a big stray field around them. Use a toroidal transformer. In that case the stray field is, say, inside of the core, and it doesn't, say, go out a lot with a toroidal transformer. So this is what it is. Mounted transformer in a very strange way. And when you want to do this, don't mount the transformer first fixed, but keep it, say, loose from the circuit, and then move it slowly into your circuit, and then turn it around a little bit and listen at the same time with the headphone whether you can pick up hum and where is the ideal position of the transformer. And you can search that out very easily with a headphone, a pre-amplifier, a headphone, etc. etc. So now we have this strange situation, transforming, hanging in the circuit here. Anyway, thanks for watching. This is pure practice, and this is, say, a problem that you can encounter, and when you cannot find the cause, your very sensitive pre-amplifier or perhaps even end-amplifier will have a persistent hum. And of course one-pointers, I've talked about that earlier. There are videos about it on my YouTube channel. Here is my one-pointers location here, at the most sensitive point of the circuit, and that is the input. So here it's grounded. This is my mask connection, and these wires here, for instance here and here, they go to that mask connection, and at the same time the tin plate of the back side here and on the front is connected via wires here. So perhaps it seems complicated, but it is simple. Thanks for watching.